Hello everyone. In today's class, we will learn meter bridge. What is that? Meter bridge. What is the topic name? Meter bridge. So what is this meter bridge and what is the principle of meter bridge? First of all, we have to learn this. So before we have learned Piston bridge and Kirchhoff's laws. In the Piston bridge, we got one condition, that is P by Q is equal to R by S. That is what? Bridge balance condition. Now, based on that condition, or that condition is nothing but principle of this meter bridge. Okay, so here I am writing principle. If someone will ask you what is the principle of meter bridge, then you can write easily like this, that it works on the principle of Piston bridge. That is P by Q is equal to R by S. That is bridge balance condition. Already we have learned this. Okay, is that clear? So first we have learned this principle of this meter bridge, and that is Piston bridge. Now, what it consists and how is the diagram for this meter bridge? Let's see. So I will draw the diagram first and then I will explain what it consists. Okay, so let's draw the diagram first and then I will explain what it consists. First of all, concentrate how I am drawing the diagram. Little space you keep up. Okay, because you have to draw some metallic strips above, so therefore you keep little space ahead. Like this first strip, and then in between you have to take another strip like this, and then again one more rectangular strip like this, right angle strips you can see. Same like how we have connected this side. Like this metallic strip, another one. See, there is two gaps are there, left gap and right gap. Okay, this one you can see, this is left gap, this is right gap. And again from this, you have to take one wire, and this wire we have to connect to battery, which is here. And one key. Can you see here? This is a key. And then complete this circuit. So this is a cell, and its EMF is capital E. This is key, and now here you are having one wire like this connected here, and whose length is 1 meter. This wire, and below you are having a scale exactly of 1 meter. This is a scale here. What is this? Scale. Meter scale. You know this meter scale, how it is. This is how much? 1 meter length. One meter or 100 centimeter. And now here you are having left gap. This is called left gap. Okay. In this left gap, there is one resistance you have to connect. So this left gap is having resistance connected R. This side it is S. And now from this you have to take one wire, and there is galvanometer connected. This is a galvanometer, and this one is what? Jockey, which will make the contact here. Now this is point. So from this point to this point you are having length L1. Which side? This to this. This is your L1. And now this side to this side, how much it is? This is how much? 100 minus L1 in centimeter. This length. That is L2 we can say. Yes. So let's give some names now. This point I am giving as a point A. This one. And here is already resistance R. This point I am denoting as a point D. This point I am denoting it as a C. Right? And this one already I told what is this? Meter scale. What is this? Meter scale. Meter scale. And current is flowing through this circuit like this. Yes, this is what I is, which is flowing here. Got it diagram? How I have drawn? Very simple. Yes. So this is left gap. So this is I am denoting with L. This is right gap. This is R. L means what? Left gap. R means right gap. Keep it in mind. G is galvanometer. This is jockey. Jockey means what? One who rides. Yes or not? Horse race में रहता है ना jockey. Same like that here also we are having jockey who will ride on this wire. Okay. So already meter bridge principle I told you. What is the principle? It works on the principle of Piston bridge. If you will see here, if I am drawing diagram as a simplification, so you can see you will get something like this diagram. This is R. Okay. This one is S. This one is resistance of wire DC, है ना? And this one is resistance of wire AD. And from this point, we are having galvanometer. Yes or not? This is a galvanometer connected. Right or wrong? So same like this. Yes or not? So here, you know what is the principle? R by R AD should be equal to S divided by R of DC, which you have to prove. Got it? Same thing you, if you will see here for this, you are getting like this. Okay, so let's start now. Some theory points. So how it is? So first one, it consists of wire AC of length 1 meter. So I'm writing like this. It consists of wire of length 1 meter. Isn't it right? You can see in the figure AC A to C point. This wire is there, no? This wire is of 1 meter. 1 meter is equal to 100 centimeter. Already I have denoted here down. Okay, next. Of uniform cross section area. Of uniform cross sectional area, or just of uniform cross section. That's it. What is my uniform cross section? That wire is there, no? It should be uniform. Everywhere, same area of cross section. Same thickness, we can say. Right? Somewhere small, somewhere more. It should not like that. It should be uniform. Next point. Next point, you see what I am writing. Next one, you see here, these two thick, this wire fixed between two, these two right angled metallic strips. Yes or not? You see here, these two are the right angled metallic strips. Next point. What is the next point? In the left gap, unknown resistance connected. In the right gap, known resistance connected. Okay, what I am writing? In the left gap, unknown resistance R is connected, and in right gap, what we have connected? Known resistance. In right gap, known resistance S is connected. Okay, you can see here. This is no unknown, this is known. R is unknown, S is known. L is what? Left gap. R is what? Right gap. Now this is galvanometer which we have connected. This is a jockey. So one more point I am writing. First of all, you note down this, pause the video, note down, draw the diagram. Doubt you have, call me. Okay, so note down first. In the diagram, you give here also one point, that is point B, this side. Okay, and this point is B. Okay, next. Now, next point. So I am writing like this. One end of galvanometer, or one terminal we can say, or one end also, no problem. One end of galvanometer is connected to point B and another end connected to jockey. I will show you this in the diagram. One end of galvanometer is connected to point B and another end connected to jockey. So let's go back. See here. Can you see this galvanometer? Yes. Can you see this? Yes, this is a galvanometer. Okay. And the one end is connected to point B, another end is connected to jockey. This arrow, can you see this arrow? Arrow means jockey here. Okay. This is a jockey. And this is a D is a balancing point. D is what? Balancing point, where this galvanometer shows zero deflection. One more time. What is D? D is a point where this galvanometer shows zero deflection, and then we can say that bridge is balanced. That is what? Balancing length L1. Got it? Okay. What is jockey? What is jockey? Okay. So see here, I am writing here what is meant by jockey. So see, the jockey is essentially is essentially a metallic rod essentially a metallic rod whose one end has whose one end has a knife edge which can slide over the wire to make connection. If you want to see the image of this jockey, you can type in Google search jockey. You can see it. Even in the labs, we are having the practicals. So when we are doing practicals or we will do practicals, that time I will show you everything clearly. Okay. Here I will show you. See here, this galvanometer to this D point, this arrow is there. No, here we will connect jockey, which will ride on this wire. So when this key we are going to close, this jockey will be in air. Then we will start from this side, and then slowly we will check where the galvanometer shows zero deflection. At which point galvanometer shows zero deflection, that point to this A point is your balancing length. Understood? One more time, listen. This galvanometer first connected to jockey, so this jockey will be in air first. So first we will start from this point A. Here we will check, is galvanometer showing zero deflection? No. Then we will go ahead again like this, again like this, again like this, again like this. At one particular length we will get zero deflection in the galvanometer. That is what your balancing length. And at that point we can say that this bridge is balanced. Okay, let's move ahead. Next point, what I am writing, see, next point. See here, the jockey can be moved along the wire at particular point or at particular length, galvanometer shows zero deflection, that is balancing length. That is what? Balancing length. At that length, we can say that bridge is balanced. Yes, in Piston bridge already we have learned this. When galvanometer shows zero deflection, we can say that bridge has balanced, and then we have derived also how we got P by Q is equal to R by S in the Piston bridge. Here also same thing, just galvanometer at one particular length you are getting zero deflection, and that is what your balancing length. You see here, I'm showing you diagram again. Can you see at D point your bridge is balanced? So I am writing here another point in a diagram. At point D, bridge is balanced and L1 is balancing length. L1 is what? Balancing length. And L2 is equal to how much? 100 minus L1. L1 is balancing length and comma L2 is equal to 100 minus L1. You can see in the diagram here. Already I have denoted. Yes. Okay. Next. Now, next point. Using bridge balance condition. Using bridge balance condition. So I am taking you backside. So here already I have denoted one. I have drawn one bridge which is equivalent of this. So I am using this condition here. So what is that? R divided by resistance of arm AD is equal to S divided by resistance of arm CD. You can see in the diagram. Okay. Resistance of this R divided by resistance of this arm AD. Obviously, we have to find the resistance of this wire, AD wire, piece of wire. And this DC, this is also wire or CD or DC, whatever you want, not an issue. So you can make, if you want, here DC, okay, instead of CD, not at all an issue. So I'm making here DC. Okay. Now we know RAD is equal to rho into L1 divided by area of cross section. Similarly, R of DC is equal to rho L2 divided by A. Yes, we know this relation. R is equal to rho L by A for a particular wire. If this is a wire and this rho is what? Specific resistance or resistivity, we can say. And A is what? Cross section. L is what? Length. You know this already, we have learned. A is what? Area. So then resistance is what? This, like this. So therefore I am writing here, we know. Okay. So R of AD we got, R of DC we got. Let's substitute here. Therefore R divided by rho L1 divided by A is equal to R divided by S divided by, है ना? Not R. This side you are having S. So this is S divided by rho L2 divided by this A. So this A will get cancelled. This row will get cancelled. So what you are getting, R divided by L1 is equal to S divided by L2. R divided by L1 is equal to S divided by L2. So therefore, can I write like this? R divided by S is equal to L1 divided by L2. And therefore, R divided by S is equal to L1. L2 is what? We know L2 is what, Ray? 100 minus L1. Is that clear? And therefore, by using this formula, we can calculate any one thing. Yes. So by using these or this formula, we can find out unknown resistance value. We can find out unknown resistance. Okay. And note point, adjusting null point near middle of the wire, error can be minimized. You know? So in this, whatever you are getting error, that we can minimize by adjusting L1 nearly equal to 50 centimeter. How? Nearly 50 centimeter. If you will adjust you can minimize the errors. Clear? Understood? So note down. Note down. Okay. So I'm sending you some problems. 2 problems only I'm sending. You solve that immediately after the class. Okay. Revise all these things and note down all the notes carefully. I'm sending you 2 questions. Solve that immediately. Okay. So let's stop here and enjoy the day. Bye.